So here's the standard form, the equation of hyperbola. So you use this one if the transverse axis is horizontal, you see? Or when it opens horizontally. Hyperbola opens sideways. Then we put x squared in front. Why? Because then if you put it in the front, it becomes positive. And as you can see, you have minus. So then y becomes negative. If it opens vertically or your transverse axis is vertical, you put what? Y first. And as you can see, then x is after negative, minus, it becomes negative. And now it's the difference. Ellipse, you add it. Hyperbola, it's the difference. And they still equal to 1. So then what is A? A is the difference between the center, or the distance between the center to its vertex. This is A, vertex. Oh, this is vertex. And this line is transverse axis. If it opens up and down, now this is your what? A. So when y comes first, A is the vertical distance from the center to the vertex. When x comes first, it's the horizontal distance from center to the vertex. So this is also vertex, and we call this point to point foci, where the difference between any distance on the ellipse, the difference becomes the same. And these are called asymptotes. Then what is B? We are going to go ahead and draw a rectangle based on A and B. So this is A, how wide your rectangle will be. And this, how much you go to the other direction, will be B. And once you get a rectangle, you're going to connect from the corner to the other corner to draw the asymptotes. So this A and B will give you the shape of the hyperbola. Okay? So let's go ahead and try an example question. So here, where's your transverse axis? Horizontal, right? So what comes first then? What comes first? X comes first. So it's X. And as you can see, just like the circle and other conic section, H and K will be the center. So you subtract H and K from the X and Y. So the center is 0, 0, which makes x minus 0 squared, which is just x squared. Remember, it's minus now for hyperbola. And you do y minus 0, which is y squared, equals to 1. And the number under x squared will be the distance from center to the vertex. So what is A? It is increasing by 2, so it's 2, 4, 6. So A is 2, this in both ways, 6 and 6. So then you put A squared, which is 36. What's under Y? You have to look at the box or asymptotes. So this is your B. So that's going to be 2, 4, 6, 8. Down 8, your B. So A squared will be 64. And as you can notice, A is not necessarily a bigger number anymore. Right? It's the direction. X is this distance. A, this is for under Y, B. And how I remember this is when you put these hyperbolas together, Doesn't it look like an X? Some people write X this way, guys. X. You see? So you have X's first. That's how I remember. Doesn't this look like a top of Y? Y, isn't it? So then you start with Y minus H. Again, the center is 0, so it's Y minus 0 squared minus X minus 0 squared equals to 1. So now you divide it by A and B squared. So now where would your A be? From center to the vertex, which will be 2, 4, 6. That's your A. 6. So then on the Y, now you put the distance from the center to vertex vertically. So it's 36. X squared, B squared will be now 8 squared, which is 64. Okay, let's draw another example. So what variable is first? We have x squared, right? So that means it's going to open horizontally. And what is A? Square root of 36. So it is 6. What's B? Square root of 64. So 8. And this time, let's just go ahead and increase the graph by 2's. Okay? Otherwise, it's going to be off the graph. So let's just increase these by 2. And what's the center? It's minus 0, minus 0. So your center is at 0, 0. So here's my center. And which axis is the transverse axis? If it opens sideways, this is your transverse axis. So this is your transverse axis going through the center. So it's going to be the x-axis, or you can write it as y equals to 0. If they ask you to write an equation, you should know how to write an equation of it. And how do you find vertices? You look at what's under your main axis. 36, so A is 6, so you do 2, 4, 6. So 6, 0. Yeah, I'm going to scale these differently. So it's 2, 4, 6, 2, 4, 6, negative 6, 0. And what do we do with B? B is 8. What you do is from the center, you go up 8, 2, 4, 6, 8. And remember, we are going to make the rectangle. 2, 4, 6, 8. And using your A and B, you're going to make a rectangle. So vertex are at negative 6, 0, and 6, 0. And what do you do with these two? You connect the diagonals, the vertices opposite to each other, and get a shape of the hyperbola. From here, this is my asymptote. This one, here's the other one. So then this gives you the shape of the hyperbola. So you start from the vertex and you try to get closer and closer to the asymptotes. So you can see how wide your hyperbola is opening. So you start from the vertex and get closer and closer to the asymptotes. And how do you find foci? It is, as you can see, foci is bigger than A and B. Usually bigger than A. So you do foci squared equals to A squared plus B squared. Now, ellipse, it was A squared minus B squared. For hyperbola, it's A squared plus B squared. So what was to find F, the distance from center to foci? What's A 6, or basically you're adding these two numbers in denominator, right? A squared is 36, B squared is 64. So you get 100 equals to F squared. So when you square root it, your F equals to 10. So then what does that mean? You go, that's a distance from center to the foci. So you go 2, 4, 6, 8, 10. 10 comma 0. From the center, you go 10 to the left, 2, 4, 6, 8, 10. Negative 10 comma 0.